Thursday, January 14th. I'm actually recording on Wednesday afternoon because I won't have time to record tomorrow. I don't have a prep. We have a meeting, a team meeting during our prep tomorrow. So I want to go over some stuff. I can see that I'm not exactly on the screens, my information behind me, so I'm going to run over there and twist that a little bit. Or move it back a little bit. There. I think we're good now. All right, so you're going to be working with the idea that, first of all, we're going to just be talking about a regular neutral atom, and we're going to use the idea that the atomic number identifies the number of protons in the nucleus of an element. It also identifies the element. We learned that yesterday. We're reviewing it today. And we're going to only work with neutral atoms. We will not be working with ions today. That's a whole, we got to get this down first. Neutral atoms, we got to get that down first. So what that means is I have the same number of protons that are positively charged as electrons, which are negatively charged. So if I have a hydrogen and it has one proton in the nucleus, which it does, hydrogen is element number 1, the atomic number is 1. So protons have a positive 1, so there's my positive 1. It will also have a neutral atom of hydrogen, which is what we'll be doing on this data table, only neutral atoms. They have to have equal number of negative and positive charges. Electrons are the negatively charged particle. So how many electrons will a hydrogen have? It'll have 1. It'll have 1 electron because it had 1 proton. And we want a neutral atom. And the math looks like this. If you add a positive 1 and a negative 1, you get 0, or a net charge of 0. It is a neutral, no charged atom. It cancels each other out. Good? Hopefully? All right. Reach out to me if you're having trouble. All right, so the atomic number identifies the number of protons, but then it also identifies the number of electrons because we're talking about neutral atoms. So whatever number of protons, you got to have the same number of electrons, okay? This information is on the worksheet that you're going to be completing. So you just have to read the information table at the top and then complete the table on the bottom. So once you know a couple of the numbers, you just have to do a little bit of easy mental math, okay? The first one that we're going to do on the board together is lithium. And we're going to do lithium is element number 3. If you look on a periodic table, it's element number 3. That means its atomic number is 3. That means the number of protons are 3. The number of electrons, 3. Now, how do I get the mass? Well, we talked yesterday about how mass equals protons plus neutrons. That's also on the key, the information at the top of your worksheet. Protons plus neutrons equal mass. Don't you forget that, because that'll make this table so easy. All right, so let's go back to our lithium. I knew that I had an atomic number of 3. So on the table, let's say it gave me my number of protons. If it gives me the number of protons, that means I know the number of electrons. So let's fill that in. So protons and electrons are the same. That also tells me the atomic number, because the atomic number equals the number of protons. So once you know the atomic number, you know 3 of the numbers. Or once you know the number of protons, you know 3 of the numbers. Once you know the number of electrons, you know 3 of the numbers. Because those numbers, protons equal electrons equal atomic number in a neutral atom, okay? Isn't that easy? All right, so the atomic number 3. There we go. Now, how am I gonna find the mass? Well, I know protons plus neutrons equals mass. So I was given protons and I was given neutrons. So 3 plus 4 equals 7. All day, every day. All right, let's try boron. Boron, I've only given you the neutrons and electrons. Okay? Can you use that electron number to identify the atomic number and the number of protons? Yes, you can, because the atomic number is the number of protons, and in a neutral atom, it is also the number of electrons, because we want to have the same number of charges. So, number of neutrons is 6, therefore the number of protons must also be, the electrons are 6, therefore the protons must also be 6. The atomic number must also be 6. If I add protons plus neutrons, I get 12. 6 plus 6 is 12. All day, every day. All right. On this one, the only information you're provided is the atomic number and the mass number. So the atomic number identifies the number of protons and the number of electrons. So if I have atomic number is 10, I know the number of electrons is 10, and I know the number of protons is 10. How do I find the number of neutrons? Protons plus neutrons equal mass. Okay, it told me I had a mass of 20. So 20 minus 10 equals 10, all day, every day. And that one is now done. All right, what if I just give you the mass number? Will you know what to do? You're like, sure, Obi, we'll figure that out. We just need our periodic table. So I tell you that the element name is aluminum. So you look at your periodic table and find aluminum. Aluminum is element 13. Aluminum is element number 13. It has an atomic number of 13. So I'm going to grab my green marker. The atomic number is 13. I found that on the periodic table in the upper right-hand corner. Okay. So that identifies the atomic number, tells me the number of electrons and the number of protons in a neutral atom. Same number of protons and electrons in a neutral atom. And then I just need to find out how many neutrons. Well, what do I add to 13 to get 27? So 27 minus 13 equals 14. And now I have aluminum done. So that's what you'll be doing on your worksheet today. All right? Good luck with that. Reach out to me if you have any questions. Hopefully you'll figure that out. You'll work through it just fine and then submit it for grade.